Time-appropriate greetings, everyone, and welcome back. Let us learn together how to do present value computations using Microsoft Excel. Let's start with a goal. Suppose that we'd like to have saved $100,000 in 15 years. Let's say that we're using a 6% annual interest rate compounded monthly. How much do we need to invest today to meet this goal? Our goal, aka a future value that we'd like to obtain, is $100,000. The annual rate is 6%. The number of years is 15. I'm just going to make this column a little larger to accommodate that long label. The number of periods per year is 12 since it's monthly. Then the total number of periods over this timeline is n and is computed 15 times 12. 180 months over a 15-year period. The per period rate R is equal to 6% divided by the number of periods in a year. Annual divided by number of periods per year, 0.005. Similar to Excel's future value built-in function, Excel has a built-in present value function. The present value function looks a lot like Excel's future value function. It still has a rate, it still has a number of periods, it still has a payment if appropriate, and it takes an optional argument, future value. We'll compare this to the formula for present value. Future value times 1 plus r to the negative n. Let's compute it both ways and show that they're the same. Using the manual formula, the present value is equal to the future value times 1 plus r to the power of negative n. Is 40,748. I'm going to format this as currency to make it a little easier to read. If we want $100,000 in 15 years using this interest rate, we need to put $40,000 in today, in the present, in order to meet that goal. Let's compute it using Excel's formula now. The present value is given by the present value function with the rate 0.005, the number of periods 180, payment is 0 since this is not an annuity, we're not adding anything every period. And the future value, $100,000. Similar to the future value computation, we need to put a negative sign in front of this. This is again negative because it's out of your pocket for the duration of these 15 years. 40,748 and 24 cents. We get the same answer. Next, let's suppose that we're looking for a loan to buy a home or a mortgage. Let's suppose that we're using a 4% interest rate compounded monthly. If the loan term is 20 years and our monthly budget payment is $1,000, how much can I borrow to buy the house? Note that this is a present value computation because the unknown quantity that we're computing is at the beginning of the 20-year period, the amount we're borrowing today. Our payment is $1,000. The annual rate is 4%. The number of years is 20. The periods per year is 12 since this is monthly. Then the per period rate R is equal to 4% divided by 12 months. And the total number of periods, n, is 20 times 12. There are 240 months in a 20-year period. The present value, then, is computed using the present value formula with the rate 0.0033333, 240 periods. The payment is $1,000, and I'm remembering to put a negative sign in front of it. And the future value is 0. Again, because this is optional, it's in square brackets, I could leave this blank and Excel will by default put a 0 there. But I'm going to put a 0 there to be 100% clear. The future value should be 0 at the end of this loan because I would hope to owe nothing at the end. I close this and hit enter, and I obtain $165,021.86. This is the mortgage we can afford on our monthly budget. If we take a loan for $165,021.86 and make $1,000 a month payments, we'll have it paid off in 20 years at 4% interest compounded monthly. Let's ask one final question. If we splurged a little bit and took out a mortgage for $200,000 instead of the $165,000, how large a payment would I need to make in order to pay this off in the 20 years? Of course, I'm going to be using the same 4% interest and the same monthly compounding. Let's add the mortgage amount to our spreadsheet for referencing. And now let's compute the payment required to pay this off in time over the 20 years. Instead of using the annoying manual payment formula, we're going to use Excel's built-in PMT function, payment, which is going to very easily calculate the payment required to pay off a loan in a certain amount of time under a certain interest rate. The payment function requires a rate, R, the number of periods, N, the present value of the annuity, which in this case is the $200,000 that we've borrowed today. I'm going to put a negative sign in front of it. And finally, the future value of this loan, which is going to be 0 when we're done paying it off. The payment is then calculated to be about $1,212. If I want to pay off this $200,000 mortgage in 20 years using 4% interest compounded monthly, I need to make monthly payments of $1,211.96. I hope you can imagine how useful present value computations are, and I hope you now appreciate how easy they are to do in Excel using Excel's built-in functions.